program at ISC 2025 was actually quite nice. So we had multiple keynotes, 3 different keynotes from 3 different continents. So we were really connecting the United States with Mark Papermaster, to Europe with Björn Stevens talking about climate and sustainability, to China with Yutong Lu, who's going to give a talk today as a closing keynote. We also had a wonderful paper session. Actually, the highlight was the Hans Moyer Award session that we had, where we had a paper that connected quantum and HPC, winning the best paper award this year. So it's all about connections.
My name is Martin Schulz. I'm from the Technical University of Munich in the Leibniz Supercomputing Center, and together with our team, with scientists from Leibniz Supercomputing Center, Technical University of Munich and Argonne National Lab, we won the Hans Moyer Award this year for the best paper, which introduced a software system that built a common stack between HPC and quantum computing. We took our HPC technology and applied it to quantum and now have a unified stack to track topologies and other information about the system.
We are still in the early days, but nevertheless we hope that when we integrate these quantum computers with the big supercomputing systems, we can have some benefit from the quantum computer as an accelerator. And this benefit can be in terms of speed, but it can also be in terms of energy efficiency. So the goal is to create workflows for our HPC systems in which we give part of the program to the quantum computer, the part in which a quantum computer can be most efficient. Then the quantum computer solves this little problem and gives the solution back to the big supercomputer, and then the big supercomputer can continue until it comes to the next step where it can again give something to the quantum computer. So we have there an iterative process.
The emerging things like quantum, and this is an area that is going to improve our life significantly across the globe and make the planet greener, healthier with green computing, taking humanity and advanced computing forward.
Connecting the dots is an excellent theme for this year because there are a lot more dots out there to connect than were in any prior year that we've attended these conferences. The biggest trend that emerged was the incorporation of newer technologies, particularly AI and quantum computing, into HPC, and what additional things will be possible because of that.
AI is just the short way to spell supercomputing at this point. The systems are the same, the bits of precision, they care less about the answers being right, so they have less bits than we do, but otherwise, it's all the same thing at this point. So really, AI is growing the supercomputing space.
If you look at the industry level for high-performance computing, scalable systems, AI has already eclipsed HPC and scientific applications, but that's precisely why the scientific community needs to get involved in also supporting, together with the AI, specific scientific applications. This is because AI works very well where for problems for which there's lots of data. Where does the data come for AI for science? It comes from science. And therefore, in order to generate enough data to train an AI, you need to have the applied mathematics that underpins science to generate sufficient amount of data so that the training can occur.
We are seeing more and more AI being applied to classic HPC number crunching, simulation type projects, both pre-processing data going into an HPC cluster, but also post-processing, analyzing the data that's coming out of that kind of modeling scenario. And if you look at AI, another way you can think of it in my mind is AI is just another workload that sits on top of an HPC infrastructure.
It's important for us to continue to push the boundaries on the science that we do. We should take advantage of all the tools given to us, whether that be high precision, low precision, as much memory as we can get, looking at new technologies like maybe silicon photonics, alternate ways of doing computing, whether it be neuromorphic or quantum. There's a lot of possibilities in the future, and it's very exciting, and I'm glad to be here and taking part.
Well, science is such a fundamental part of how the world operates, and we need to have young people, we need to have resources, we need to have the ability to carry out science and to communicate with colleagues around the world.
ISC has been for 40 years. I've been involved for 14 years in ISC. I was also yesterday in a panel about the diversity and inclusivity that ISC is striving towards. And I really feel that in these 40 years, ISC has made this conference a very safe and welcoming place for everyone who is interested in HPC, actually working in HPC, or people like me who are more on the communication side, who have no idea about core hours and whatever, but still feel that they're part of the community.
I have visited conferences before, but this one is more personalized. I feel like the community is really nice. It's like very connected, so it's great.
Hey guys, we're here at ISC 2025. I'm here at the Vidura booth. I love technology. I'm so curious about AI and technology, so it's exciting for me to be here as a partner with Vidura. And we just finished some great challenge. It was fun to get the crowd involved and the people involved within this, and we had some really strong people. But thankfully, I came on top. It was close though.